All right, so like I said, this will be 7.1. And this one deals with symmetry. Okay, so there's 3 types of symmetry we're going to look at in this section. So the first symmetry is what we call symmetric to the y-axis. All right, y'all, so for a graph to be symmetric to the y-axis, if I fold that graph over the y-axis and it lands on itself, that makes it symmetric to the y-axis. So if folding the graph, all right, let me let one in real quick. So if folding the graph over the y-axis, and the graph lands on itself, then it is definitely symmetric to the y-axis. So I'll give you an example of some graphs that are symmetric to the y-axis. So let me draw this first one here. So parabolas look like a U. But notice if I take this graph and I fold it over the y-axis, this right side will land exactly on that left side. Okay. Another example. Could be my absolute value. My absolute value graph comes up like a V. Okay, but if I took that graph and folded it over, it would land on itself. So that makes it symmetric to the y-axis. All right, second symmetry is what we call symmetric to the x-axis. And basically, I check it the same way. I fold the graph over the x-axis, and if it lands on itself, then symmetric to the x. So if folding the graph along the x-axis, and the graph lands on itself, then like we said, it is symmetric to the x-axis. All right, so let me do a few examples of symmetric to the x-axis. All right, so let's see, to be symmetric to the x-axis, I could have a curvy graph coming to the right and on the bottom. You'll notice if I take the top of this graph and fold it over to x, this top part will land right on that bottom part, okay? And then how about a graph that looks like a V turned on its side? Same thing here. I fold it over, it's going to land right on itself. So y-axis folded on the y, x-axis folded on the x. We got one more type of symmetry. And this one we call symmetric to the origin. And y'all remember the origin is the center of the graph where the x and y axes are crossing each other. So to be symmetric to the origin, if we rotate the graph, so if rotating the graph 180 degrees, so basically you're turning it upside down. So if rotating the graph 180 degrees yields the same graph, then it is symmetric to the origin. All right, so let me show you a couple of those. All righty, so the cubic graph sort of comes uphill, goes through the center, and then turns uphill. Now watch this graph. You see what it looks like. Now, if I take my page and turn my graph upside down, notice my graph is still going uphill, left to right. And it looks like the same graph. So since when I turn that upside down, it looks like the same graph, that makes it symmetric to my origin, okay? All right, a couple more things we need to know about this. When we go back to this, to be symmetric to the y-axis, we often call that an even function. That means to be symmetric to the y-axis, it's going to have an even exponent, such as the x squared graphs here, okay? Now, over here at the origin, when it's symmetric to the origin, we call those odd functions because they're going to have odd exponents, okay? Also, odd functions cross the x-axis an odd number of times. So they're going to cross the x-axis an odd number of times. Which means if we go back to the one that was symmetric to the y-axis over here, even functions, they're going to cross the x-axis. So they cross x-axis an even number of times. Or not at all. So what I mean by that, this parabola over here that I did for my first one, if that parabola was up a little higher, notice it's still an even function, but it's not crossing the x-axis. So even functions are the only ones that will not cross the x-axis if that graph is lifted up. Odd functions always cross the x-axis. Now you're wondering about this symmetric to the x-axis. Y'all, the reason it's not an even function or an odd function is if I did my vertical line test, that thing intersects twice, which means it's not even a function. So when they're symmetric to the x-axis, remember, it's not a function because it violates those vertical line tests, okay? So let's see what they're going to do with us on this homework here. So let me get my page ready. All right, so for this first problem here, they want us to determine if the graph is symmetric to the x-axis, y-axis, or the origin. Okay, so I'm just going to draw some pictures and we'll determine what we think this is. So for number one, so there's my x and y. All right, so number one sort of tricky. On the right side, it curves up, and then it curves down like that. This side comes down first, goes up, and then heads off to the right. Now my drawing's not exactly perfect like the math lab would draw this. So you would check it, the y-axis folded over. Well, this hump would hit over here, so it's not landing on itself. Then you would check it on the x-axis folded over. Well, this part would land down here, so it's not landing on itself. Then my other check would be to turn it upside down 180 degrees. And notice I basically still have the same picture as when I started. So since I can turn this, let's see what my chat's saying. All right, so chat saying origin, which is definitely correct. That graph is definitely symmetric to the origin. Good job.
Why?
Why? Because remember,
Yeah.
you see what this graph looks like, right?
Yeah.
It sort of comes down and then the other side goes up and comes down. Now, watch that picture. Now, notice when I turn it over, I still have this side coming down, this side going up and then down.
Oh, okay.
So it's basically the same picture when I turn it upside down.
Oh, okay. Okay, thank you.
Okay. Now theirs will look better in math lab. All right, for this one, it comes down, sort of does that to that side. Left side comes down and sort of does that on that side. All right, so what y'all guessing on that? Oh, y'all are quick. That said y-axis, and that's it, right? Take my graph, I fold it over the y-axis. This right side right here will land exactly on that left side. So good job. This one is definitely the y-axis. And when you're looking at the y-axis and the x-axis, what they mean by symmetry on those is it's almost a mirror image of the two sides, right? Versus that y sort of being the divider. Now, number three starts right here on the x-axis, goes that way, goes down here, and goes that way. That's what y'all thinking. Ooh, that's quick. I got 2 or 3 staying the x-axis, and that's perfect. If I take my graph, fold it over the x-axis, this part right here will land exactly on that part. All right, so now that y'all know that, let's see what y'all do on these next 2 questions. So these want to know, is the function even, odd, or neither. Now remember, if it's even, it's going to be symmetric to the y-axis. If it's odd, it's going to be symmetric to the origin, okay? So let's see what they got on this first one. So for this one, it looks sort of like a graph that comes down and stops right on the x-axis on that side, and then does the same thing on the left side. All right, let me let one in real quick. So that was lemur. So, all right. Oh man, you are quick. Okay, so I got a neither and an even. So remember, if it's symmetric to the y-axis, it's going to be even. So if I do take this graph and fold it over to y, this side will land on that side. Also, look at this, y'all. It's touching my x-axis twice, which is an even number. So this one would actually be an even function. All righty, y'all. Let's see. Trying to figure out how to draw this one. So this one comes up, goes through the center, and then goes up that way. All right, so even, odd. Okay, you're quick. Those are saying odd, and that's correct. Odd because if I flip it upside down, I'll have the same picture. So it's symmetric to the origin. Also, it's crossing my origin just one time, which also makes that an odd, okay? All right, also, guess what? That's 7.1. So now we're going to start 7.2. So you only got 5 homework problems on that section.
Was it a picture on there showing us like what neither looked like or no?
Oh, they didn't. Oh, let's see. So neither could be something like this. So I had a graph here, and it's sort of V's. But remember, this one would be, it's not symmetric to anything, right? It's not symmetric to the X. Not symmetric to the Y or the origin. So when it's not symmetric to anything like that, then this would be neither.
Thank you.
But I think on the homework, all they're going to do is give you they'll give you 2 like I did. And one will probably be odd, one will be even. All right, so 7.2, we're going to start moving these graphs around. So this is transformations. All right, so I sent a sheet in your email last night or this morning, I can't remember. I think it was this morning. I sent an email to you that had a file of the basic shapes. Now I'm going to draw them right here, but we're going to take these basic graphs and they're the ones we're going to move around on here, okay? So we got about 7 basic graphs we're about to draw. So the first one will be the graph of a line. So that line is going to shoot straight through the center here. This is the graph of y equals x. So that's the most basic line graph you can have. Next, we have our parabola that comes off the center here. Our parabola, this is the graph of y equals x squared. So the basic x squared graphs, remember, all had their low points at the origin. All righty, we got one that looks like a sharp V in here. Remember, the V graphs were the absolute value. So this would be y equals the absolute value of x. So y'all, this little chart we're making here with these basic graphs is a good one to sort of keep handy for when you do the homework and the test later. All right, this one will be the one that I had going sort of uphill, crosses through the middle and goes uphill. This is the basic graph of x cubed. All right, this one sort of goes to the right. This one would be y equals the square root of x. Now remember, this graph can't go to the left side on the x's because we cannot take square roots of negative numbers. Those give us our imaginary numbers. So the square root graph starts in the center and just goes to the right. Now a cube root will be even flatter than the square roots. But y'all guess what? Cube roots can go both ways. So this is y equals the cube root of x. Remember, cube roots can have negative x's because a negative times a negative times a negative is a negative. We just can't do that with square roots, okay? All right, then we got one more. And this is what we call y equals 1 over x. It's like the reciprocal. So this reciprocal graph on the right side comes down and sort of goes along the x's. And on the left side, it's sort of under and goes like that. Now, we won't have to graph these by hand. These are just what we call the basic shapes. Okay, so keep this one handy because what we'll do, we're going to move these graphs left, right, up and down, and we'll flip them depending on what moves we make, okay? All right, so I'm going to give you the types of moves we can do to these basic graphs.
Can you flip it over just one more time really quickly?
Okay.
Thank you. Okay. Okay, I got it. Thank you.
All right. And then I'm going to be showing you when we start doing the homework problems how to put these in MathLab because that's the trickiest part of this homework is doing these moves in the MathLab, okay? So, transformations. And we got 3 transformations we're going to look at in this section. The first one would be a vertical transformation. For a vertical transformation, you're going to have y equals f of x plus or minus some number at the end. So plus or minus means I can make this positive or make it negative. If that b is positive, if b is positive, it will move my graph up. So it moves up b units. So if that's a positive 5, it's going to move my graph up 5 units. If the b is negative, then that's going to move down B units. So notice what, to get graphs like this, you're going to have something like y equals x squared plus 3. Notice my basic graph is y equals x squared. So I start with the x squared graph, and what that plus 3 is doing, it's going to move my graph up 3 units. Okay. Another example of that could be y equals, let me think of my other lines. How about this one? Y equals x cubed minus 5. So for this one, the basic graph is y equals x to the third. And that negative 5 at the end is moving my graph down 5 units. So y'all, the main thing I wanted y'all to see, that to change the vertical position of it, to go up or down, you're just adding numbers to the end of the function, okay? Second type of transformation is a horizontal. Now y'all notice the difference. For me to do a horizontal transformation, I'm going to have y equals f of x plus or minus a. So before I just added the number to the end, now I'm changing the x values with these a's, okay? I'm attacking the x. So if you're inside parentheses, you're basically going to be doing a horizontal move. So here's the funny part on this one, though. If the a is positive, this graph will move left. All right, let me get one in real quick. All right. So the graph will move left. A units. Well, it's sort of backwards to me. I always thought, well, okay, I got my x's. If I add to the x's, it's going to move me right. But no, that's not true. If you add to them x's, it's going to move it to the left. And then if a is negative, then the graph moves right a units. So watch how I'll do the x squared graph and the x cubed, and I'll show you the difference on the two. So an example could be y equals x minus 2 squared. So notice the difference. Up here, we just put the number at the outside of that function. Now we're actually changing the x's of the function. So this would be a basic graph. Y equals x squared. And by subtracting 2, it's going to move my graph right 2 units. Okay. I'll do one with a positive a. How about y equals square root of x plus 3. Now, what you got to realize, square roots, we treat them like they're almost in parentheses. So we're still attacking the x inside parentheses. So our basic graph is y equals the square root of x. And by adding 3 to the x, it's actually going to move me left 3 units. All right, so let me pull this down just a little bit. So my third move is what we call a reflection, and we're going to reflect over the x-axis. Now, they'll try to mess you up in this homework and put stuff like reflect over the y-axis, but you're never going to reflect anything over the y-axis in this section. We'll do that kind of stuff, but it'll be when we hit chapter 9, okay? So for this section, you're only reflecting over the x-axis. So to get that, you're going to have y equals negative f of x. So you're putting a negative in front of the function. That's going to change all the signs, which then kicks it over the x-axis. So an example could be y equals negative x squared. So if you y'all had some questions on my test with a negative in front of the x squared, remember that took that parabola and that turns that parabola upside down and reflects it over the x, okay? So for this one, my basic graph is y equals x squared, and then that negative reflects over the x-axis. Hey y'all, so that's our moves we're going to look at on these homework problems. And then on these, I'm actually going to show you how to graph them in MathLab. So I'll give y'all a second to write these notes. And I think this section had like 8 or 9 homework problems. All right, so let me move this back up. So what I'm going to share is my screen with the actual homework problems so we can get a problem and I'll show you how they do these. All right, so let me move my cat over a second. So number one, I got what? Y equals, so let me write this down. Y equals, parentheses, x plus 7 squared. So we got to figure out what that plus 7 is doing to my graph. So remember, it's inside the parentheses. So what y'all think that plus 7 is doing to my graph?
Moving it up 7.
Oh, so I got an up 7. But remember, on this one, that plus 7 is not on the end of this. So to move it up 7, it would be x squared plus my 7. Remember that 7 can't be inside parentheses to move up or down. So y'all, it's inside the parentheses. We said that's going to move me left or right. And since it's being added, it'll actually move left. So you're going to come down here and pick the one that says move left 7 units, which is D. Now what you got to do is come down here and tell it what the basic graph was. So for this one, it would have been the x to the square. So punch your x. And then you square it. Now, at that point, you're going to check your answer. Oh, internet's slow for me. Now, graphing it. This is the part I need to show you. I'm going to click on enlarge graph. Now remember, we know what picture the x squared graphs look like. They look like a parabola, which looks like a U. So to graph these, you click on the tool you're using, the U, and you just click anywhere on the graph. All right, click. It'll draw a parabola on the graph. It draws the basic parabola. But remember, we said this one's going to move left 7 units. So when you click that parabola onto the graph, it opens up this little box over here. You see vertical stretch and shrink, which we won't mess with. Horizontal stretch and shrink, we won't mess with. We're mainly worried about the vertical shift down here, horizontal shift, or if we reflect it over the x-axis. So since mine went left 7, I would come down here to the horizontal and click that cursor until I got to a -7 on the left side. So I'm a little touchy. Let me go back one. All right, so I'm at -7, but y'all notice, look at my graph. It moved it for me when I used that slider control. It moved my graph from the center all the way left 7 units. So then that was the only move. So you would save that. And then you click your check answer. Let me see what I did. Let me pull my graph back up. Oh, I moved it too far. Okay. Okay. So let me clear that. So I'll grab my parabola, click on the graph anywhere, and then move that horizontal to -7 and not -8. All right, I think I'm on -7 this time. Save it and check. All right, also let's see what number 2 has. Now, this is the only one that you got to plot by points because it's a straight line. So remember, this is the basic graph of y equals x, and that -7 on this one does move it down 7 units. So you would click A, start with the graph of y equals x, and we said we're shifting this one down 7 units. So check that. Now, like I said, this is the only one where you got to physically get 2 points to graph it. So it is a straight line. So let me go to the line tool. Which is right here. All right, now the line tool, like I said, you got to come up with 2 points. So I'm going to say if I let x equals 7, y would be 0. So I'm going to go to 7, 0. Ooh, let's see, these are small. So right there. And then let's see, if I let x equals 0, that would give me -7. So I'm going to go to 0.
Ow!
-7. Oh, what was the question? Okay. But notice, y'all, this graph used to go right through the center, y equals x. It's now 7 units down. And then check that one. All right, hx equals 1/x plus 5. And they're telling you, hey, the basic graph was the 1/x that we drew. So that plus 5 at the end, what is it doing to my graph? So that's on y'all.
Making it go to the left.
Oh, so let me see what you're, so I heard it left. Is that going left? Because remember, this is the one where you got your f of x and you're adding that 5 at the end. So what was my first transformations I gave y'all?
So this is up 5 units.
It's going to go up 5 units. There you go. So this would say 5 units up. Now, watch this. When you check this one, it's going to have us pick one of these answers, A, B, or C.
B.
So B, yeah, because A looks like the basic graph, right? The one I showed you. B went up, and it looks like C went down. Now remember though, you can graph any of these in your calculator and it'll show you what's happening to them. So look here, you got negative x plus 9 to the third. Since you got that exponent 3, the basic graph is going to be the x to the third graph. Now we just got to figure out what that 9's doing inside these parentheses, and then what's that negative doing in the front. And y'all, I want y'all to look. There's no way this will be A and D because they're talking about the y-axis. We don't reflect nothing on the y-axis, so you can throw out A and D. So it's going to be B or C. So is that 9 shifting me right 9 units, or is it moving me left 9 units?
Right.
Oh, so Cindy's so close, but remember, when you add inside those parentheses, it's opposite what you think. You would think that'd go to the right, but it actually goes to the left. So y'all would have to go with C on that one. All right, but the function was what? X to the third. So we got X, and then we do our exponent 3. And it's going to shift left 9 units and reflect across the X. So when you check that answer, remember, it's going to bring up the graph. So the X to the third tool, remember, that was that squiggly looking line. So our basic graph will be the X cubed tool. Remember, click anywhere on there, it's going to stick it where it wants it. We move 9 left. Woo, that's horizontal, left 9. So let's move that to -9. And then down here, it says reflect over the x-axis. You got to click that little box, highlight it, and notice what it did. So watch when I unclick it. My graph was going uphill left to right, but when I reflected over the x, it's now going downhill left to right. All right, so that's the only 2 moves on that. So you're going to click save, and then you're going to check your answer, okay? So I was happy about this section. It didn't make me block points on these. So look here, describe how that g of x equals x plus 2 squared minus 4 can be obtained from one of those basic graphs. So the first thing we want to figure out, what's the basic graph? And that would be what, my x squared graph, because you see that exponent 2 sitting there. So that's going to be your x squared graph. So do your x and then put your exponent 2. Now, it says shift it blank 2 units. Well, that 2 is inside those parentheses. So when you add 2 to the x inside the parentheses, it's going left to right. So since this is a positive 2, it's going to move me left 2 units. And then what's that? It's saying, what about the 4 units? So at the end, that's a -4. So remember, when you add numbers to the end of it, positives up, negative would be down. So this is going to go down 4 units. So we punch that in. So I got all my moves. So I hit check answer. And then guess what? We're going to graph this. So click on your graph. That's an x squared. So remember, it's going to look like a parabola, which is the u. Pick the u and put it somewhere on that graph and click. All right, we had two moves. That +2 we said was going to move us left 2 units. So come down to your horizontal and hold that down until you get it on -2. Then you had a vertical of -4. So go to your vertical shift and pull that down to -4. So I got my 2 moves in. I saved that. Notice my graph did move left and down. So hoping I clicked on the right numbers, I will just check it now and be done. All right, y'all got questions on the graphing yet? All right, I'm doing pretty good. All right, so guess what? This one's telling you, hey, this is the basic graph of g of x equals the square root of x. All we want to know is what is that +1 doing under that radical? So y'all, here's the thing. When it's under the radical, it's like it's in parentheses. And when it's in parentheses, it's the one that's moving left or right. So since we added 1, we're actually going to shift this thing left. What is that? 1 unit. All right, so let's check that. Now this one I think has pictures we look at. So y'all, one of these looks like it went left. So let's see. Well, you can barely tell, but it looks like A is to the left of the y-axis, and it only went 1, so it looks like A went left 1 unit here. So I'm going to click A and check that answer. All right, what's this, number 7? They're saying, hey, how can the cube root of x plus 3 be obtained from the graph of the cube root of x? So they're telling me what the basic graph was that cube root of x. So what in the world is that +3 doing to this graph? Oh, so I'm getting y'all on this one. Now notice the difference. To move left 3, remember that +3 would have to be under that radical, okay? Like it was in parentheses. But remember, this +3 is just tacked on at the end of it. So this would be your first transformation we went over, which is either going to go up or down. So that +3 being positive is definitely going to go up 3 units. Good job. And let's see if they want us to graph this one. All right, so which one of them went up, A, B, or C?
C.
C, perfect. I guess it only gives you one chance on that one, huh? It said final check. All right, y'all, the last one. We got negative x minus 2 in parentheses squared plus 3. So this one has 3 moves. We're going to start with the graph of x squared. So that +2, is that moving me left 2 or right 2? So y'all were saying, right? So I went right 2 units. So I'm going to shift right 2 units. Then reflect across the, well, remember, we ain't done nothing with the y-axis, so that's got to be the x. Good job. And then let me move this out of my way here. And then shift it. The +3 is doing what? So that's going to go up 3. Good job. And then check your answer. Y'all get these. It just takes a little time playing with them. Y'all getting a lot better just now. Oh, that one don't make us, we don't have to graph that one. So y'all, that is the homework. So let me go back to my pad. Oh, I'll just quit my share. I guess I'm done with that. All right, let me see what my chat's saying. Good job, Cindy. That's right. Good job. All right, y'all. Questions on that? So 7-1 and 7-2, I wanted to keep it a little mild since y'all had a test this week. So my test 1 is due Sunday night. You definitely want to try that study guide before you do my test. And remember, the study guide counts as a quiz, okay? And we did all 25 questions the other day, and I sent y'all a video for that. The bonus, if you do the bonus and send it back in an email or text, I will add them points once you do your test. Okay. So y'all, any questions for me? All right, so I will release y'all for the week, and I will see y'all Tuesday night. And good luck on my test. Oh, I thought I heard something.
Are you staying after for support?
If you need support, I'll knock out some support with you.
I do.
Okay, so let me let all these off of here. We'll stop our recording and then